I want to, first of all, I want to thank everyone who joined this call, and Khalifeh, thanks for your time, and our community members, thanks for, that you found time to join us today. Our guest is Khalifeh AlJadda, who is Senior Director of Online Data Science at the Home Depot. And he will be sharing how they build search and recommendation systems at scale to help people to discover relevant to them products, and sort of facilitate more this online purchases. Thanks a lot, Khalifeh, and we're looking forward to hearing from you.
Thank you. Thanks for having me, and thanks everyone for joining us today. So, we have a limited time, so for that reason, I would like just to go ahead and start. So, a little bit about my background. Because many people sometimes ask, like, how did you get into the data science, and how do you get into the leadership roles in data science? So, I have a PhD degree in computer science from the University of Georgia, and my entire academic life was in computer science. So, bachelor's, master's, PhD, all computer science. And then I started my career as a data science intern at Career Builder when I was in the PhD program. That's the first advice I would give everyone. If you are still a student, try to get an internship. And then I joined full-time to lead the search and recommendation data science teams for Career Builder. At that point, we were building the semantic search engine for the company and the AI-based recommender system. And both of them are in production today. After that, I moved to Home Depot to lead the core recommendation data science team as a senior manager. And then I got promoted to director of data science to lead the search and recommendation. Then after that, senior director to oversee the entire online data science portfolio. I'm also serving as a member of the advisory board on the School of Data Science and Analytics at Kennesaw State University. I'm serving on the advisory board of the computer science department at University of Georgia. And I worked as a senior research scientist at Georgia State University. Also on the community side, I'm the founder of the Southern Data Science Conference, which is an annual event. It will take place this year in September in Atlanta in person after 2 years of being virtual. And a co-founder of the Atlanta Analytics for Community Service, which is a nonprofit organization. Now let's get to the fun part. E-commerce is known to be a very rich domain in data. And this is just an example here to show it's not just rich in data, it is also rich in modalities. So it's multimodal data. So if you take now a snippet from the product information page on any e-commerce website, and I took here this information from a product information page from Home Depot. As you can see, you will see, or you will find on the product information page, the product image. And usually there's not one single image for the product. You will find multiple images that pictures the product from different angles with lifestyle, blah, blah, blah. And then there is text data, which is, you can see in the title and description. And there is tabular data, which is what you see in the table of attributes of that product, key value pairs. And then you can see the variations of the color of that product, which is another aspect of visual data. And then you see user-generated content, the reviews, and you see the rates, the stars. And then behind the scene, there is a very rich source of data, which is the clickstream data. And in the clickstream data, you get the clicks, add to cart, purchase, and so on. So when you build a search or recommender system for the e-commerce, you should leverage this rich data asset and the multimodality of the data in order to solve different problems and satisfy different users' needs. And we're going to see in this talk a few examples of how the multimodality is helping solving those customer pain points by leveraging this very rich data assets. Let's get to the first use case, collection recommendation. And I actually added as a footnote here the research paper that we published, which has all the details about this work. And it was published at the ACM RICSIS 2019 conference. And the name of the paper is Product Collection Recommendation in Online Retail. So what is the problem with the collection recommendation? we are a home improvement company. So when people come to homedepot.com, they usually work on a project which requires multiple items, not a single item or a single product. So for example, if someone came to Home Depot and they're working on their bathroom renovation project, and they liked this faucet, the bathroom faucet that you see in the current product box. So in our terminology, in e-commerce, we call this now the anchor product. So they like this faucet, which is now an anchor product, and like they're not here just to buy the faucet, right? So they need shower head, towel bar, towel ring. They need the shower knob. All these items needs to match the style, the color finishing. Like there needs to be harmony between them, right? And for that reason, usually we put this piece of recommendation on the website, which shows like, here is an anchor product faucet that you like. Here are the other like items that can form a collection with this faucet to complete your bathroom look. Cool. Well, we talked already about now the requirement, how we define a collection. But then the question, how to create this collection? It was a manual process until the data science team actually automated that process. And we're going to talk today about how did we automate that process of creating those collections. So basically, we looked at the data assets that we have, and we figured out that based on the definition of a collection, those products have or complement each other functionally, and then they have a visual harmony between them. Visual harmony in this case means that they have the same color finishing, or similar color finishing, not the exact same, and they have the similar style and feeling. So with that in mind, then we decided to build a multimodal machine learning model that actually leverage the image to extract the visual aspects of the product, and the text to extract all the metadata that we need about the product, like the model number, the brand, all the category that the product belongs to. Because you're not here, again, you're not here looking to similar products. Like I want product A to be similar to product B. No, you're looking into complement set of products. Product A, I want to identify product B can form a collection with it or not. And we give the definition of the collection, or product C can form a collection or not, and so on. So here is the technical details of the solution. As I said, we took actually two modality or of the data, the text and the images, and we wanted to leverage those together to generate the collection. So the first thing you do is you want to take the anchor product image that you want to generate a collection for. And in this case, because we want to show you it's not just for faucets, actually for any other product or category that sometimes needs a collection. So we're taking here a patio furniture. So you can take this chair from a patio furniture, and you want to form or generate a collection for this chair. So you take it, and then now you need to extract the visual aspects of this product. As we said, the visual aspects here, the color finishing, the style. And then on the other hand, you need to leverage all the metadata that exists in the text, in the title and description of the product to find the other products that can form a collection. So in this slide, as you can see, we take the image of the product, and then we actually train the bidirectional LSTM on the pairs of products that form a collection. So you have positive examples for the products that are in the same collection, negative examples if they are if they are not in the same collection or they shouldn't form a collection. And then you take the representation, in this case, like the vector embeddings or the representation from the text and the image, and then you try to merge them, and then you try to find the other products that actually have or can form a collection with this product. So let's get into the LSTM, the Siamese network that we built for the text. So this part is basically how we process the text, the title and the description. And in this case, what we do is we take the title description of product A, title description of product B, and then we send them and we train a Siamese network bidirectional LSTM. And the training data, if you ask, where did you get the training data from? As I said, there was a manual process to create those collections. So we have manually curated and created collections on the website already when we started this project. So we took those, but that process is not scalable, as you know. So we took those as our training data because it's manually labeled data. So we would take a product A and a product B from a manually created collection, and then we would, as positive example, and you would take product A and product C who are not from the same collection as a negative example, and then you would train this network. At the end of the day, after you train this network should be trained now to understand if I feed title description of product A, a title description of product B, it's gonna spit out 1 if they should belong to the same collection, -1 if they shouldn't belong to the same collection from the text perspective. Then it comes to the image, like how do we generate the or extract the visual features from the image? And for this specific project, at the beginning when we published this paper, we actually tried to use Resonate to see if we can extract. But Resonate, if you take it as is the pre-trained network, it was trained actually to find similar products. So if you feed into the network a bench like this white one, it's gonna return all these as matches. But in our case, we're not looking for similar product. Like I don't want to give a chair and get chairs. I want to feed into a chair, but I want to get the color finishing representation of that product, so I can match them against the color finishing and the style of the other products that I'm gonna match them with this anchor product. So for that reason, we actually implemented a traditional computer vision model, which is the color histogram. And with the color histogram, we were able to take the visual features or extract the visual features that we want from the image and use that representation or that embeddings then to find the other products that should form a collection. So this is a very interesting chart. So what we did is we said, okay, maybe the visual embeddings or representation of the product is enough, and we shouldn't look at the text. And in this case, we should drop the entire like Siamese network that we built. Because if I take 2 images of products, maybe the images can tell me if they should belong to the same collection or not. So we did test using only the visual features versus using the visual and text, the multimodal learning that we created. And as you can see, the blue is the visual features only, and the red is the multimodal. And as you can see, across all the subcategories of the PADU data set that we have, the multimodal learning model outperformed the visual only features. And that was very interesting, again, because that reflects the importance of using the multimodal or the modality that we have in our data, the different modality. So at the end, once you take now the similarity based on the image features, the visual features, and the similarity based on the text features between the 2 products, how do you calculate the final score? So our combined score is basically a weighted score. So there is a way to the similarity based on the text. There is a way to the similarity based on the colors or the visual features. And then you can actually play with those weights based on the importance of each one of those components. For example, in the power tools, do you really care about the visual features of the product? You don't. So you care more about the metadata in this case. You want the comparability, the voltage, the brand, things to match. But in furniture or in the bathroom or in kitchen, the visual features are very important. So for those ones, maybe you would want to put more weight on the visual similarity than the text similarity. In this slide, we are showing an example of a collection that was generated by this model for the anchor product, which is in this case, this golden faucet. And as you can see, the model predicted that all these like vanity, sink, mirror, lights, those should or can form a collection with this faucet. And you can see this is like a very good matches. So that's about the first project, which is the collection recommendation. And it is an example from how we leverage, again, the data assets that we have on the recommendation or in the recommendation engine. Now, I want to now give the second example from the search engine. And usually when you hear talks about the search engine, the focus is in most of the talks about search is about the retrieval engine, like the matching engine. So you will hear a lot of talks about leveraging the deep learning to build vector search for the matches, or learning to rank for the sorting and ranking. But what is interesting today is I'm going to actually cover a totally new area where deep learning and data science is helping to remove some friction from the customer's shopping journey when they use a search engine, which is based on the search experience. We refer to this as the search experience. So again, this work was published as well in the SIG-IR 21 in the e-com workshop at SIG-IR 21. The name of the paper is Featured Keywords Enabling Product Discovery in E-commerce Through Unstructured Product Attributes. If you would like to get all the technical details about this work, you can download that paper and read it. But let's talk about the problem that we try to solve here. Faceted search is the king in e-commerce. Faceted search is when you conduct a search in any e-commerce website, you will see those facets or filters that appear on the left navigation, the left nav of the page, of the search results page. And then usually customers engage with those filters to kind of drill down their focus, their search into a specific set of products based on their interest, either could be based on a specific attribute, the size, or the color, or the model, or things like that. And then the search engine also is gonna react to that by start showing only the things that match the filters which the user applied on the left nav. The question is, how do we get those attributes that appear on the left nav, those facets or those filters? Who decides about what to show there? Historically, those filters come from the domain experts, in this case, like the merchants or the category experience people. They decide what are the filters or facets they want to show with each set of categories in the catalog. And then the search engine is going to basically pull those or facet the results according to those attributes, which again came from the domain experts, the merchants or the category experience. And that's a static set or a static list of attributes. Now the question is, what is the problem with that? The problem with that is the customers sometimes have different needs that is not reflected or represented in those filters or attributes. And there's no way that you can actually learn or infer those attributes from the customer's input, right? Because they are a static list that comes from the domain experts in the company. And for that reason, this project that we created here, our goal was, how can we create smart facets? Smart facet means that those facets are dynamic and we learn them from the customer's behavioral data. So let's take a look at the system design. This is an overview of the system design here. So in this project, what we do is we take the search log and we look at what the customers usually search for with, that attributes they search for when they submit the queries into our search engine. So, for example, for the ceiling fan query, we figure out that users usually search for a large room ceiling fan. Now, the question is, if you go to our facets, the static ones, do you see large room as one of the attributes that you can filter the results according to it? The answer is no. Okay, then how can we make that happen? How can we take the input from the users and aggregated input from our aggregated wisdom, in this case from the users, and then enable that to become one of the filters based on the customer's need? So you take the input from the users as one side of the story, and the second side of the story in this case is the product title and description, the aspects or the attributes or the features mentioned as a free text, unstructured data in the title or description. And then what you want to see is when the customer use those attributes to search for the term, do we usually see those attributes like large room appear in the title or description? Because if they don't, then there's no way you can filter according to those. But if they exist, then you can actually extract them and then start filter according to the mentioning of those attributes in the product description. So long story short, you take the input from the customers through the queries, and then you take the input from the product title and description, and then you basically identify the attributes that can appear or exist in the title and description and can be used as a filters. And then you rank them and you take the top ones and you show them in the facets or in the lift navigation panel. And as you can see here, so if in the next query that come to the system, someone searched for ceiling fan, after we learned that large room is an important attribute, then on the lift nav, you will see that large rooms appear now as an attribute or a filter, which the customer can use then to see only the ceiling fans that are appropriate for large rooms. Cool, here is the more detailed system design. You take the customer behavioral data, you take the product metadata, you do a keyword extraction, and then you do from the search history as well. And then you calculate a score, which we call keyword product relevance, query product relevance. You rank those attributes or extracted aspects of the product, and then you do clustering to dedupe, and then you get the final list ranked based on their importance to the customers. And then based on this list, you decide which ones to show or to add to the filters. For the sake of time, I'm going to just a little bit rush now the slide. But for the keyword extraction, what we do from the title and description, we absolutely leverage the POS patterns, the part of speech patterns. So we analyze the title, description, highlights, bullets, and for example, we identify that you should extract the adjective, noun, and verb combination whenever they appear in the text, because then the adjective would be one of the attributes that we should highlight. Or you can take the noun adjective combination. So examples: high performance finish, 5 years warrant, resistance of fading, removing water from flooded basement, low-lying collection spots, and so on. So we absolutely do some keyword cleaning after we extract those, TF-IDF to remove insignificant words, and then you limit the words length to between 2 and 5, and then you run the dedupe between those keywords. Okay, now once I extract those important attributes keywords from the product title descriptions, then what we do is we come now to the ranking. Like, how are we going to rank and filter out the less important attributes and only keep the important ones? For that reason, then we go to the customer submitted queries, the search log. And then what we do is we calculate a score called query product relevance. The query product relevance in this case means if the customer submit a query like hammer, right? How many times they order this type of hammer and how many times they order that type of hammer, right? And in this case, each of those hammers is a different product, right? And then for each of those products, we have extracted set of attributes. So for this hammer, the extracted set of attributes from the previous phase was rubber head, fiberglass handle. For this one, the extracted attributes were steel head, shock reduction grip. So what basically this score is saying is the importance of the attributes that we extracted depends on how popular is the product with that query to our customers. Like how many times our customers, when submit that query, they end up buying this product. So the keywords that we extracted from that product, those are more important than the ones that came from a product which our customers did not end up buying with that query. And then there is here another score that we calculate, which is keyword product relevance. And the keyword product relevance, in this case, it means that the keyword itself, which the customer put in the search box, right? How important are they to the products that we have? And in this case, I want to know if fiberglass handle versus, for example, steel head, which one is more important than the other one? So again, it comes back to how often our customers end up buying a specific product when they use that attribute or feature in the query formation. So when they type the query and they use this attribute, which product they end up buying, and this is where we identify the products that are more important to this specific attribute with the query. And then you combine those two products with, again, in a weighted way. So this is alpha, and there is 1 minus alpha, keyword product relevance, and then 1 minus alpha query product relevance. And then you come up with this rank score for the keyword given product and the query. Cool. Then we come to the dedupe. And for the Ddupe, what we do is we take lexical similarity and we take semantic similarity. The lexical similarity is you look at the intersection between like the common keywords between the extracted attributes and the union of them. And then so mini refrigerator, small refrigerator, and a small fridge, so you just take that, and then this gives you an idea if there is similarity, lexical similarity. And there is semantic similarity, and the semantic similarity if things are mentioned in not lexically in the same word, the same set of words, but they mean the same thing, so synonyms. And for that one, we use actually the word-to-vec, and with the word-to-vec, you calculate the cosine similarity between the keywords, and that's going to give you an idea of how similar are those two keywords. So you create those clusters based on the semantic similarity and lexical similarity, and then accordingly you choose, after you cluster those keywords, you choose the representative of each cluster, and that representative is the top ranked keyword based on the ranking score that we calculated the previous phase. And with that, basically each one of those representative keywords in each cluster is taken and added into the lift navigation, the lift nav as a filter. When we tested this model, or the output of this model, we ran an A/B test for 2 weeks. The results came positive. Engagement increased by 2%. Engagement means customers actually are using the filter. Average order value increased by 2.9%, which means customers now finding their products in a more convenient way. And revenue per visit increased by 3.6%, which means, again, more people are finding what they're looking for and they are buying. I know I have only 25 minutes, so I'm done. You have tons of materials you didn't need to, we didn't need to go over it now, but I'm giving a talk on the GTC next week, March 22nd, to cover the rest of those use cases. And it is free, the NVIDIA Conference. So you can watch that talk to get more insights about the other projects that we have here. This is just to acknowledge the team. I'm just presenting their work. They're actually the people who have done the work. So kudos to all of them. And we are hiring. So if you are interested in the work that I presented today, please feel free to reach out to me at my email. Thank you all.
Thanks, Khalifeh. Guys, if you have questions, you can unmute yourself and ask directly. I see some questions in the chat. Just a second.
Sure.
How much manually labeled data do you have?
So we have a lot, I can tell you. So we have usually data that exists already because of the manual process that exists before we create the data science teams and start automate things. But also we use vendors and other manual annotators to help us annotate when we don't have enough data. But we have a lot, because to train deep learning models, you need a lot of data, except if it is unsupervised learning. So for that reason, actually, we either use in-house annotators, as I said, like the domain experts who already created some labeled data for us, or if we don't have enough, then we usually use vendors to annotate data for us.
I have a question, please. In Simon's network that you showed, you use LSTM. Why did you choose LSTM instead of like a CNN?
Yeah, usually when we end up like choosing a model, it means because we tried or we tested the other models and it didn't outperform the one that which we end up choosing. So again, like the technical details are in the paper that we have, but for this kind of problem and kind of representation, CNN did not give the best results, and LSTM actually ended up giving the better results, and that's why we end up using the LSTM.
Cool. Thank you.
Sure.
Okay, I see a question from Steve. Is product description data only available through the analysis of the unstructured product description? Is there no structured product data stored in a product database that can be used?
Great question. So when I put in the first slide sample of the data that you find on the website, yes, there are some extracted and key value pairs data that represent the major attributes of the product. But those are not everything that you need to learn about the products. And usually sometimes they suffer from either wrong values, missing values, things like that. So when we try to use that tabular data or the key value pairs that are already extracted from the product description and listed as product attributes, we end up with poor results. So it was kind of a must to do NLP and text mining to extract everything we need from the product description free text instead of using the already structured attributes about the product.
Mm-hmm. Okay, I see a question from Prahlad. How are you handling incorporation of new products for which you might not have much customer clicks or keyword search information?
Yeah, that's a great question. And the answer is you rely on the content-based matching. For that reason, we have, like, if you think about the CMS network, we trained one to basically learn if two things belong to the same collection. So we trained actually a deep learning model to measure similarity between the products. And then you can measure or you can find similar products that have customer behavioral data to the ones that got onboarded with the cold start problem. And then this way you can solve the cold start problem. So you have to rely on the content-based matching to solve the cold start problem for the new onboarded items into our catalog.
Mm-hmm. I see a question from Vladimir. How do you check significance of your deep models, in this case, CMS, in terms of the ranking problems? I mean, improvements of the models.
So we have offline, we have two things that we do. We have offline evaluation where absolutely you have like a test data set which you can test against and then find out if the improvement that comes with each iteration or each model they introduce. But then we have also a tool which we deploy the results of the models into a random selection of the results of the model. And then we have manual annotators who go actually and evaluate the results and give us a human feedback, thumbs up, thumbs down. And then we get that as this kind of the secondary evaluation. And based on that, then we decide if we are happy with the performance of the model at that point, then the next step is we take the model into an A/B test. So it's kind of 3 phases of evaluation. You start with the offline evaluation using the test data set that you have. And then if it passes, then you send it to the manual validation or human validation through a validation tool that we built in-house. And then if it passes that, then it goes into an A/B test. And then based on the A/B test results is the final decision is made if it should go into production or not.
How often do you guys update your models that are in production?
Depends on the models and the volatility of the data that we use to train the model. So some models got refreshed on weekly basis. Others sometimes needs to be like on monthly. Others needs to be on a quarterly basis. So it depends on the data that we use to train that model.
And I'm curious, do you guys build internally those tools, to monitor for deployment models for monitoring, or you are using some open source frameworks for that? Like how do you internally make those decisions to use to build yourselves or like use vendors
build or buy is always a debate, and it's not. But for us, if there is a tool available already and it is good enough for our need, then we don't have problem using tools already exist. We are a big GCP shop, Google Cloud Platform shop. So whatever services and tools that comes with GCP that we can leverage right away, we would leverage. But if we don't have it, then we need it, then we usually go ahead and build it in-house.
What are your thoughts on training your own models versus using pre-trained ones like BERT, like T5 and so on?
Yeah, great question. So I mentioned in the collection recommendation that we actually took the ResNet as is pre-trained and we wanted to use it, try to use it. So we usually start with the pre-trained. If you want to use the pre-trained models, we usually start by leveraging the pre-trained as is, and we then evaluate the results. And if it is good enough, then there's no need to retrain. However, in most cases, it turned out that the pre-trained model doesn't actually perform well on the downstream tasks. And we have to kind of freeze and chop some layers and train a new layer or layers for our need. And then it works fine. So we don't train everything from scratch, never happen if there is a pre-trained model. But in most cases, we have to kind of customize the training by freeze and chop some layers and then train our own layers to do the tasks that we need. The other about BERT, especially that in the last conference of wisdom, which was 2 weeks ago or 3 weeks ago, we actually published a paper called CAT-BERT. CAT-BERT is the catalog BERT model, language model. So we took the pre-trained BERT language model, but instead of using the pre-trained model, the generic one, we actually retrain it using the domain, the data we have in our catalog, like the products metadata that we have in our catalog. So, and all the results are showing significant improvement over the general BERT. So that's very interesting research project that we have published this year at Wisdom in one of the workshops there. And it highlights the importance of the domain-specific language models instead of the generic language models, especially we're talking about the language models here. So yes, we retrain as needed. If the pre-train is good enough, we would use it, but most of the cases we retrain as needed.
Mm-hmm. So I see another question. How do you monitor the models that are deployed?
Very, very, very great question. So we monitor the models that are deployed through a dedicated, actually, there's a dedicated team in my organization that is built to just track the performance of the models. And when we track the performance, we see actually we track the business KPIs that we care about after deploying the model, as well as we track the outcome of the model itself by looking into NDCG, for example, as one of the relevancy scores that you look at on the business metrics. You want to look at the click-through rate and the engagement rate and the conversion rate. So if you see a dip, then absolutely that's alarming. And then we go ahead and we try to revisit what's going on and analyze and see if the problem is with the model that was deployed. It drifted and it become outdated, or if it is something else. But we continuously monitor the performance, and we get that team actually is do a daily update of the dashboards that we track the performance of the models on. And whenever we see a dip, then we get into that and we investigate to find out what is going on there. But it is a continuous process, and it is not easy process, I can tell you.
So for this model monitoring, do you use any kind of third-party product like Fiddler or something like that, or you develop something on your own?
No, at this point, we're not using any products or vendor products. We are actually using our in-house solution. Yeah.
Mm-hmm. Mm-hmm. Okay, I see a question from Steve. Do the product manufacturers interested in helping with your efforts, or is it all on you?
I would say it's yeah, I know they're talking about the vendors, and I would say yes. I mean, they're responsive. So whenever we send some feedback or things about the products metadata or things like that, they're responsive most of the time.
Mm-hmm.
Yeah.
I noticed you guys using let's say LSTMs, the sort of well-established architectures that have been used for a while. Did you guys try those more modern language models like GPT family models, or you think that those proven architectures there perform much better for your tasks?
We haven't actually played with GPT or things like that because again, when you work in an industry, one thing you should always bear in mind is what the production environment supports and what it doesn't support. Mm-hmm. So if you want to use GPT, the first thing you should ask is your production environment support GPT, right? And the other thing in the industry also you should always think about is the cost. If you want to use GPT, can you justify the cost from the results that you're getting, right? So for those reasons, I don't think as of now we have worked with the GPT. However, we run a research collaboration program with many universities in the US. And one of the research projects that we are running now is actually to try to test the GPT compared to the other, like especially the CatBERT that we created model, a domain-specific language model, as well as see that try to optimize GPT for our own goals or tasks. So we are running now a research project in that area. It's just a research project. It's not something that we are actively working on to deploy in production, blah, blah. But it is a research project that we're running, and we didn't know what the results would look like at the end of that research project.
Okay. I saw Jeff earlier asked if there are links to your papers. I think maybe we can, first of all, post your presentation on our Slack, right? And
sure.
If you also could share like links to your work, I would also be happy to share with our community as well.
Absolutely, my pleasure. And usually if you go just to my Google Scholar page, you will find most of those papers, if not all of them, already listed there.
So, sounds good. Yeah, I will just find that that page and we'll share.
Sure.
Guys, do you have other questions?
Thank you very much for setting this up.
Yeah,
Thank
sure.
you.
I see Vladimir asking. There is a good investigation of GPT-3 embeddings in ranking problems by Niels Reimers. Oh, okay, so basically, yeah, he's sharing. It's
nice.
Thanks a lot, Vladimir. Thanks for sharing. Okay, cool. Yeah.
All right.
So might be useful for your research work.
Yeah, thank you.
If you guys don't have other questions, I think we can wrap up our meetup today, and the video recording will be available like in a week or so. I will definitely share with you, Khalifeh, and with our community. I see a question on what kind of roles are you guys hiring?
We have multiple roles from associate data scientist all the way to senior manager data science. So associate data scientist, senior data scientist, lead data scientist, manager, and senior manager data scientist, all the levels.
Cool. So I think in your you will share your presentation so people can find your email there, and or what is the process? Should they send to a specific email their resumes if they want to connect, or send email to you?
Yeah, absolutely. They are welcome to send me directly through my email or on LinkedIn. So I'll be happy to pass their resumes to our recruiter and hiring managers.
Awesome. Thanks a lot. Thanks for your time. Thanks, guys, for joining this talk today. I'm again posting the link to our bug out Slack. Please join, and we'll post in all materials there. And thanks for your time, Khalifeh. It was really insightful and interesting to learn about how your work at Home Depot.
Thank you for having me. Thank you all for attending. Have a good one.
Thanks.
Bye.
Bye-bye. Have a nice day.
Bye.